In the unforgiving calculus of modern aerial combat, where outcomes are dictated by the brutal physics of flight, the spectral dance of electronic warfare, and the razor's edge of human decision-making under extreme duress, every design choice is a calculated wager. The precise curvature of a wing, the specific formulation of a radar-absorbent coating, the arrangement of an engine intake, each is a variable in an equation of survival. Into this high-stakes arena, the People's Republic of China has thrust its latest and most ambitious entry, the Feihong FH-97 program. This is not merely an aircraft. It is an attempt to fundamentally rewrite the arithmetic of air power. The evolution of this platform from a conceptual shadow of an American unmanned combat aerial vehicle, UCAV, to a sophisticated, combat-oriented system that mirrors an Australian design is far more than a simple act of industrial imitation. It represents a highly agile, strategically deliberate, and accelerated effort by China's defense industrial base to leapfrog developmental stages and field a credible, collaborative combat aircraft, CCA capability, thereby challenging the established timelines and doctrines of Western air power. The story of the FH-97 is the story of a nation in a hurry, determined to master the next chapter of warfare before its rivals have finished writing the first draft. Subscribe to our channel so you don't miss new videos on the latest in military technology. The genesis of the program became public at the 2021 Zhuhai Air Show, where a scale model of the FH-97 was unveiled, marking China's formal entry into the high-speed, stealthy UCAV wingman competition. The initial design was an exercise in what could be charitably described as convergent evolution, or perhaps just very diligent study of publicly available materials. The airframe featured a single-engine configuration fed by a top-mounted dorsal air intake, a trapezoidal fuselage with distinct chined edges, and a V-shaped tail. This planform was a near-identical echo of the American Kratos XQ-58A Valkyrie, a machine born from the philosophy of low-cost attritability. The engineering choices were telling. A single dorsal intake, while effective for maintaining a low radar cross-section from below and simplifying the design, is prone to airflow disruption at high angles of attack, suggesting the initial concept was not optimized for the extreme maneuvering of within visual range air combat. The V-tail offered a standard compromise between stealth and control authority for this class of vehicle. This initial FH-97 was marketed as a high-speed, stealthy, multi-purpose platform intended for ground attack, reconnaissance, and the suppression of enemy air defenses, SEAD. Its developers at the Aerospace Times Feihong Technology Corporation, ATFTC, a subsidiary of the state-owned China Aerospace Science and Technology Corporation, KSC, claimed a combat radius of 1,000 kilometers and an endurance of over 6 hours, establishing a respectable operational reach. Key feature was its ability to deploy the smaller FH-901 loitering munition, underscoring its focus on striking mobile or time-sensitive ground targets. This first iteration was, in essence, a Valkyrie with Chinese characteristics. It was a logical, low-risk entry into the CCA field, a platform designed to master the fundamentals of a penetrating, expendable UCAV. Its primary mission was to kick down the door for more valuable manned assets by conducting dangerous seed missions and absorbing the enemy's initial volley of fire, a role perfectly aligned with its single-engine, cost-effective design philosophy. At the 2022 Zhuhai Air Show, just 1 year after the first model's debut, ATFTC unveiled the FH-97A, and in doing so, demonstrated a stunning pivot in design philosophy. This was no incremental upgrade, it was a complete metamorphosis. The single engine was gone, replaced by a twin-engine configuration for higher performance and redundancy. The Valkyrie-style dorsal intake was supplanted by a pair of side-mounted diverterless supersonic inlets, DSIs, a sophisticated feature common to modern stealth fighters like the Chengdu J-20 and Lockheed Martin F-35, designed to manage airflow at high speeds while maintaining low observability. The primary electro-optical infrared (EO/IR) sensor, previously slung under the fuselage in a position ideal for observing the ground, was relocated to the top of the nose, a clear optimization for an air-to-air role where the primary field of view is up and around, not down. The weapons bay was reconfigured from a general-purpose space for ground attack munitions to a specialized system featuring a pop-out launcher for air-to-air missiles. It appeared the designers had updated their subscription to a different set of aerospace journals, as the new Muse was unmistakably Boeing Australia's MQ-28 Ghostbat. The FH-97A's new overall plan form, particularly its downward-sloping nose, wing shape, and DSI placement, was a dead ringer for the Australian loyal wingman. This rapid and radical redesign reveals a core tenet of China's defense industrial strategy: highly responsive and adaptive fast following. The one-year turnaround for a complete airframe overhaul is exceptionally fast, suggesting that either the People's Liberation Army Air Force, PLAAF, had a sudden and dramatic shift in its operational requirements, or that a thorough analysis of the Ghostbat's design revealed a more promising path for manned-unmanned teaming in a high-intensity air superiority context. This industrial agility, while rooted in a derivative design process, allows China to bypass years of foundational research and development, pivot resources to what it perceives as the most advanced global standard, and compress development timelines to a degree that Western procurement programs, with their often Byzantine processes, would find impossible. A detailed technical dissection of the FH-97A reveals a machine designed not as a disposable drone, but as a fully fledged, uncrewed combat aircraft. While specific material compositions remain classified, the emphasis on a low observation design and high performance necessitates the extensive use of advanced carbon fiber composites to reduce weight and radar-absorbent materials or structural techniques to minimize its radar cross-section. The primary method of achieving stealth, however, is through its shaping. The blended wing body, carefully aligned edges, and the DSI intakes are all engineered to deflect radar energy away from the source. The twin-engine power plant is a cornerstone of this new design. Chief designer Deng Shuai explicitly cited the need for improved flight speed, maneuverability, and reliability as the rationale for this change, noting that if one engine fails, the other can ensure the mission is completed. Although no official performance metrics have been released, its intended role alongside the supersonic J-20 and its advanced DSI intakes strongly suggest a design capable of sustained high subsonic or transonic speeds, allowing it to keep pace with its manned leader during dynamic combat maneuvers. The sensor suite is that of a dedicated aerial bodyguard. The primary EO/IR sensor is housed in a stealthy, faceted, gold-tinted windowed enclosure atop the nose, optimized for passively detecting and tracking airborne targets. This is supplemented by additional side-looking sensors, indicated by similar transparencies on the forward fuselage, which provide a wide field of regard for enhanced situational awareness. This distributed aperture system allows the drone to act as an extension of the pilot's own senses, passively scanning the battle space from multiple angles without emitting a telltale radar signal. Its teeth are carried internally to preserve its stealth profile. The main weapons bay features a pop-out launcher designed to carry up to 8 smaller, intelligent air-to-air missiles. This implies a focus on a high volume of fire, potentially for defensive counter-air roles, like intercepting incoming cruise missiles, or for overwhelming an adversary's fighter screen. It also retains a degree of multi-role capability, with the ability to carry loitering munitions or external pods for electronic warfare, reconnaissance, or extra fuel when stealth is not the paramount concern. The platform is also designed for significant operational flexibility. While capable of conventional takeoff and landing from prepared runways, it is also engineered for rocket booster-assisted takeoff and arrested recovery. Deng Shuai confirmed that provisions for a strengthened landing gear and a tailhook for carrier operations were incorporated into the design from its inception, signaling a clear intent for future naval deployment. The sum of these technical features, twin engines, advanced aerodynamics, a multi-spectral passive sensor suite, and navalization potential, points to a complex and likely expensive military asset. While it may be more expendable than a manned fighter, the FH-97A is not a cheap, disposable drone, suggesting the PLAF is pursuing a tiered CCA strategy with high-performance platforms like the FH-97A at the top end. The operational doctrine envisioned for the FH-97A represents a fundamental shift in the PLAF's conception of air combat, moving from a platform-centric model to a network-centric system of systems approach. It is explicitly designed to function as a loyal wingman for the J-20 stealth fighter, described by its chief designer as a combination of a sensor and ammunition depot and an intelligent assistant for pilots. In this capacity, it performs several critical roles. It can act as a forward sensor, flying ahead of the manned formation to detect threats first using its passive sensors. This allows it to provide early warning and fire control data to the J-20, enabling the manned pilot to orchestrate an engagement long before their own aircraft is detected. Equipped with jamming pods, it can serve as a dedicated CAD platform, penetrating contested airspace to electronically suppress and paralyze enemy air defenses, thereby creating a safe corridor for the main strike package. Perhaps its most crucial role is that of a force multiplier, acting as an external bomb bay for the J-20. A stealth fighter's greatest limitation is its small internal weapons capacity. A J-20 might carry only 4 to 6 long-range missiles. By teaming with 2 FH-97As, each carrying 8 missiles, the J-20's combat element could bring over 20 missiles to a fight, a dramatic increase in firepower that could overwhelm any adversary. Finally, it serves as an expendable shield, designed to draw and absorb enemy fire to protect the invaluable human pilot and their far more expensive manned aircraft. This entire concept is enabled by a sophisticated and resilient command and control architecture. The system is built around a distributed mesh data-sharing network that allows for seamless, high-bandwidth communication between the J-20 and its unmanned escorts. The airborne data link is a multi-band system designed for compatibility with a range of existing PLAF aircraft without requiring extensive modifications to the manned platforms. The drone itself is AI-piloted, capable of autonomous formation, flying and executing complex mission tasks as part of a closed-loop attack chain directed by the human pilot. This transforms the pilot's role from a hands-on operator to a battlefield manager, a commander of a small, lethal aerial formation. This doctrine aims to mitigate the inherent weaknesses of stealth fighters, namely their limited payload and high cost, while amplifying their greatest strengths of low observability and superior situational awareness, creating a combat ecosystem where the whole is far more lethal and survivable than the sum of its parts. On the global chessboard of military aviation, the FH-97A's rapid evolution places it in direct comparison with its Western counterparts. The original FH-97 concept was a clear analog to the Kratos XQ-58A Valkyrie, a platform born from the USAF's Low-Cost Attritable Aircraft Technology Initiative. The Valkyrie emphasizes affordability and expendability, powered by a single commercial turbofan engine and designed for long-range strike and surveillance missions with a modest payload of 544 kg and a range of 5,556 km. The FH-97A, however, has pivoted away from this philosophy. Its twin-engine, air combat-focused design suggests a higher performance and almost certainly more expensive asset built for kinematic performance as a true fighter escort. The more direct and revealing comparison is with the Boeing MQ-28 Ghostbat. Here, the design convergence is undeniable. Both are twin-engine, high-performance UCAVs designed for manned-unmanned teaming. The Ghostbat is approximately 11.7 meters long with a range exceeding 3,700 kilometers, and like the FH-97A, it features a modular nose for different sensor payloads and an internal weapons bay. The critical differentiator and the largest unknown lies in the maturity of the underlying artificial intelligence and control software. The MQ-28 has undergone a rigorous flight test program with the Royal Australian Air Force, logging hundreds of flight hours and demonstrating successful teaming with manned aircraft like the E-7A Wedgetail Airborne Early Warning and Control Platform. The FH-97A's operational maturity, despite its prominent appearances in parade rehearsals, remains opaque. By shifting its design to so closely emulate the Ghostbat, China has signaled a clear ambition to compete at the highest end of the CCA capability spectrum, focusing on the technologically demanding air-to-air mission rather than simply fielding a mass of low-cost, attritable strike drones. The strategic outlook for the Feihong FH-97 program has evolved as quickly as its airframe. It has transitioned from an airshow mock-up, easily dismissed by some observers as vaporware, to a physical asset prominently displayed in rehearsals for major national military parades. This progression strongly indicates that the FH-97 is a funded, active, and high-priority development program that has reached at least the advanced prototype stage and is being positioned as a near-term operational capability for the PLAF. Prospects for its future modernization are already being openly discussed by its designers. Chief designer Deng Shuai has confirmed that aerial refueling is a planned future upgrade, a capability that would dramatically extend the drone's operational radius and on-station persistence, mirroring concepts also being explored for the MQ-28. Furthermore, the design's built-in provisions for naval operations could see a variant deployed from China's growing fleet of aircraft carriers and large-deck amphibious assault ships, providing a powerful, long-range, and semi-expendable air defense and strike capability for the fleet. However, significant challenges remain. The single greatest hurdle is the development of robust, reliable, and trusted AI capable of executing combat functions in the chaotic, high-speed, and electronically contested environment of modern air warfare. The entire operational concept also hinges on the resilience of its secure, high-bandwidth data links. An adversary capable of jamming, spoofing, or severing these links could neutralize the system entirely. Finally, the program faces a strategic cost paradox. As the FH-97A becomes more capable, it also becomes more expensive, potentially making commanders hesitant to risk it in the very high-threat roles for which it was conceived. In conclusion, the Feihong FH-97A represents a credible and rapidly maturing Chinese effort to field a high-performance loyal wingman. While critical questions about the sophistication of its core AI and the security of its data networks persist, its prominent public displays signal the PLAF's intent to deploy this transformative capability far sooner than many Western timelines, which project similar systems becoming operational closer to 2029. The FH-97A is not merely a new piece of hardware, it is the physical embodiment of a doctrinal revolution toward a new era of hybrid, manned-unmanned air combat, a future that China appears determined to enter first. The final verdict on its battlefield effectiveness awaits the unforgiving audit of real-world conflict. But its development alone has already reshaped the strategic landscape and accelerated the global race for the future of air power. This doctrinal revolution extends beyond a single platform, fundamentally altering the role of the human pilot and signaling a broader strategic pivot by the Feihong. The pairing of the FH-97A with the J-20 is intended to free the manned aircraft from the most immediate and dangerous frontline tasks, allowing it to specialize in higher-level functions like command and control, data distribution, and communication disruption. The human pilot is thus liberated from the high-stress environment of direct engagement, evolving from a stick-and-rudder operator into the commander of a distributed aerial task force. This concept is further solidified by the emergence of the two-seat J-20's, a variant whose second crew member is widely believed to be a dedicated battle manager tasked with controlling loyal wingman drones. The modification of a frontline stealth fighter to include a dedicated drone controller is perhaps the most concrete evidence of the PLAF's deep commitment to this new warfighting paradigm. The FH-97A is not an outlier, but a key player in a much larger cast. Satellite imagery from parade preparations has revealed a diverse portfolio of at least 5 different CCA-type designs, including larger tailless flying wing UCAVs like the GJ-11 Sharpsword, pointing to a tiered and multi-layered approach to unmanned combat. This suggests a strategic decision to bypass a clean-sheet 6th-generation fighter program in the Western sense, and instead achieve a generational leap by augmenting its existing 5th-generation fleet with a sophisticated and scalable ecosystem of autonomous systems. This approach aims to achieve affordable mass, diluting an adversary's numerical and technological advantages through a distributed, resilient, and more expendable force structure. This entire architecture, however, is built upon a foundation of software. The most advanced airframe is useless without a correspondingly advanced AI pilot, and the most powerful combat network is nullified if its data links can be severed. The ultimate success or failure of the FH-97A and its brethren will not be determined by their aerodynamic performance or payload capacity, but by the maturity and resilience of the artificial intelligence and secure communications that bind the human-machine team together in the crucible of an electronically contested battle space.